Okay, welcome to academic Daddy class. Angle of electric field. So when we talk about angle of electric field, first you need to understand that there cannot be just one electric field. When we have different collections of electric field, we think of what we call electric flux. And the electric flux in a medium or on a surface is defined as electric flux is defined as the total electric field or the collection of electric field on a surface, and the surface is given by area. So product of electric field and area is electric flux. So if I know this, it simply means that if I have, for example, let's say a disc. Let's say I use a sphere. Let's say this is a sphere. Or let's say I use a circle. Then I have a point charge here. Now this charge can move this way. There are cases where it can move this way, 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 whichever way. Now when this charge is moving, when this point charge, I'm using point charge, when it's moving outside at this angle, normal line is always this way. So when it's moving at this angle, we say that it is moving parallel to normal line. So let's say electric field is here. So we can see that in this case, EA will be the same thing as saying EA cos phi, not theta, cos phi. So it's always meaning angle that connects electric field and normal line. So the angle, so cos phi, not cos theta, is the angle between electric field and normal line. So in this case, because they are moving in the same direction, let's say I have this and I have this, so they are at zero, is the same point. If I have, for example, something this way, then I still have the same other line this way. They are moving in the same direction, so they are parallel to each other. So, and because they are moving in the same direction, we say that this is 0, and cos 0 is 1. So EA times 1 is simply EA. So that means that you can note it down. That means that when electric field, when the angle between the electric field, I say electric field intensity, told you to always see the same. You can give different definition, but if you get deep into this course, you see that it's almost the same thing. Well, when the angle between the electric field E and the normal line is parallel, you have electric flux to be equals to EA cos 0. And that is going to be the same thing as saying EA because cos 0 is 1. But a case of second case, let's say I have a second case. Let me still maintain this first example we started with. So let's say I have a second case, and let's say in this second case, I have, let me use another thing now. Let's say I have a cylinder, but in whichever way, let's say I have this. Then I have point charge here. I don't want to use point charges, so you don't get confused. So this point charge, let's say in this case it is moving normal line. We know that normal line is this way, but let's say that the electric field considered, which we know that in this case is this way. Yes. So because there will be no, if you come to this surface, you will see that there is no, because the charges are moving this way and this way, there will be no electric field here, because by the time electric field is moving this way and normal line is this way. So even on this one now, watch, yes. So let me use this side and check it. So you see that if this charge is going this way, everything is going this way, and this is the normal line. If I want to find the electric field here, it will be the same thing as saying E and A. E and A. A that I mean is this surface. Then normal line is this one. This is the normal line. So A for surface, if you like, don't put it. So I will now do EA cos phi. And notice that the angle formed by this is 90 degrees. Remember we said that electric field moves this way in a cylinder. this way, horizontally on the cylinder. So this will now be the same thing as saying EA cos 90. And we know that cos 90 is equals to 0. So EA cos 0, EA times 0, sorry, will be equals to 0. So there will be no electric flux. So electric flux here will be nothing. There will be no electric flux on the surface of this cylinder. That's why you see us doing an example where we say that there will be no electric flux on the surface of cylinder. Go and watch my videos on electric flux introduction. You see how I explain this using a cylindrical cup. Now, we can also have a third case. This third case, let's assume that I have, let's say, something like a box this way. And I know that if this is a charge, let's say this charge is in here. I don't have much space remaining. If this charge is in here, this charge can go in this direction, go in this direction, go in this direction, go in this direction. But let's say the electric field I'm considering is this one at this angle. Let's say the electric field I'm considering is the one that flows from this angle. So you can see that if this is the normal line, vertically, and this charge is going this way. So let me draw it. It's more like having normal line this way now, and I'm now having electric field going this way. So normal line. So you can now see that if you check it very well, the angle made with the horizontal, this is horizontal, is what we call theta. The angle made with the horizontal is what is called theta. So the other angle, that is the angle between E, electric field, and the parallel and the normal line. This is E now and the normal line. So the angle between electric field and the vertical, or you say normal line, is what we call phi. So in this case, let's say if this place is 30 degrees, that means that everything on this is 90 degrees. That means that this will simply be 90 minus 30. So phi here will be equals to 60. Go and watch my video on trigonometry. So if phi is 60 here, that means that if you want to calculate electric flux for this kind of case, it will simply be EA cos phi. And phi here is 60 degrees. So it might be, maybe assuming this angle here is like 25. What you now do is everything here is 90. So 90 minus 25, you get what is remaining here, which is like 75. So that is it for angles of electric field. So now that you know angles of electric field, in our next class, we'll treat proof that EA is equals to charge over permittivity of free space. Thank you. Subscribe.